Hello there, everyone. Welcome to episode number 676 of this here electronic engineering podcast called Amelia's Weekly Fish Fry, brought to you by eejournal.com and written, produced, and hosted by yours truly, Amelia Dalton. Folks, I have been excited to share this interview for some time. My guest is an absolute rock star in the world of electronic engineering. Sandra Rivera joins me this week. Sandra and I chat about what drew her to VSORA, an emerging AI accelerator startup from France that is taking the world of AI inference by storm, the importance of inference for AI proliferation, and what sets VSORA apart from the rest of the pack. Oh, yeah, and a little bit about llamas, too. So, without further ado, please welcome Sandra to Fish Fry. Hi, Sandra. Thank you so much for joining me.
Thank you for having me on, Amelia.
Absolutely. Okay, so let's talk about VSORA. So, what attracted you to VSORA, an emerging AI accelerator startup from France that wants to take on the world of AI inference?
Well, I think you just stated it best. An emerging AI inference chip company based in France. Like those things don't typically go together. And I have to say that when I first was introduced to the company and the CEO, it was really more out of curiosity that I wanted to meet them because I built these chips in my previous lives, working for a very large semiconductor manufacturing company, and I had never heard of Visora. So when I met them and met the CEO, I was just so fascinated by the fact that here's a company that is on leading edge process technology, leading edge packaging capability, building what is arguably a chip for the most exciting growth part of AI going forward, which is not so much training because that's relegated to a few that can afford training those frontier models, but more the deployment in the inference space. And I was, again, curious. And then when I learned that they were indeed on leading edge technology with such a small, nimble team, and that team had been together for many years, building and delivering to the market successful chips. I felt it was highly differentiated because many of the startups, Amelia, as you know, in this space, they're very bright, very capable architects and engineers, but they don't have a history of working together and delivering products to the market. And here's a company that had something like 14 successful chips delivered in the past and now working on the most complex one that they'd ever done around AI inference.
So, Sandra, why has inference become so important to AI proliferation? And what makes VSORA's architecture especially valuable for inference in particular?
Great question. So the reason inference is the highest growth part of that, call it AI continuum, is because it is actually what happens when you go and deploy the AI models, whether that's in a data center, whether that's in an enterprise infrastructure environment, or whether that's all the way out to edge devices and physical AI, robots, autonomous vehicles, drones, those types of technologies and devices. And this is where the implementations and deployments vary broadly in terms of the actual use cases, but where things like cost per token, power constraints, area constraints, weight, physical weight and area constraints are really driving a lot of the obstacles that need to be overcome for these types of applications to be deployed at scale. And so because it is so wide open in terms of the number of applications, the use cases, the physical environment, those constraints, the type of almost unlimited compute power and energy and money that goes into training frontier foundational models is not applicable to inference when you're talking about much, much smaller devices or much more power and cost constraints, and where frankly, latency and determinism really matter. So that latency, that time to that first token in terms of responsiveness of the platform, and also in terms of just the deterministic outcome, meaning that if you're doing some type of, call it robotic surgery. Like you really need for it to be the same every time in terms of the responsiveness when you're actually working with the different tools. So this is what makes it so different from training and why we believe, and it's not just us. I mean, one of the things that we've seen is that there's actually a lot of startups and a lot of competitors in this AI inference space that are coming to market. But this is where there seems to be a much broader appetite from customers for solutions that are more bespoke to their problem statement, which is different from training with, again, many more constraints. But it's also where we see that it is not a one size fits all. So if you have a general purpose GPU that does very well in the training domain, it will do the job in inference, Amelia, but you'll pay more, it'll be less deterministic, it'll be more power hungry, and it'll be more inefficient than something that was more specifically designed for an inference deployment.
Sure. So this inference challenge in data center chips is closely watched and a very competitive market. So how are you guys different?
Yes. So the focus that this company has had, VSORA, has really been around addressing the memory wall problem. And just very simply, what happens in any AI deployment is that you have the compute and you have the memory. And the data that moves between the compute and the memory is actually something that most of the developers are trying to tackle because that data movement creates latencies, a lot of power inefficiencies, just the power that is required to move between, again, the compute and the memory. And it also introduces a lot of cost if you think about the compute sitting idle, waiting to be fed data. So what VSORA has done, and they've done it with a patented approach in terms of how they've built their software architecture, is that they have addressed this memory wall by creating a software architecture that really collapses down many of the layers of memory between the processing unit and that external memory. And by collapsing those layers, fusing the operators, combining it into one set of instructions and really through their compiler, it just allows that memory to look much more like registers and near memory. And from that perspective, it allows the actual operation to happen faster and for that movement to be a lot less distant, if you will, from the processing unit to the external memory. So just collapsing those layers allows more efficient data movement, more efficient software compilation, and less idle time of that processing unit sitting there waiting to be fed data.
Can you give my listeners an update about VSORA's recent successful tape out?
Yes. So this is pretty exciting. This is a big year for us, Amelia, because I mentioned earlier that this is a team that's delivered many chips to market in the past, both in a previous instantiation of a company that had a successful exit, as well as VSORA when they were formed in 2015, which was around an automotive and an autonomous vehicle type of focus. They pivoted to AI inference in 2022, and they had focused on this unique software architecture, addressing the memory wall problem, and then designing a very complex chip on latest process and packaging technology. We taped out that chip at the end of last year. We are expecting it back from TSMC in early May, and we're very excited because all of our simulated measurement that we've done and all the analysis that we've done shows that we will have a 3x performance improvement over the leading GPU and alternative solutions in the market at half of the power. So much more power efficient, much greater performance throughput, and with this greater level of determinism, lower latency, and of course, lower cost. So this year, we get our chip back. We will be putting that in an OEM module. We're working with server providers, with rack providers, so that we can actually deliver to customers that are waiting to take the product at the end of the year. They can take it in a way that's more consumable and easy for them to deploy by providing the modules, the server, and the rack architecture, which again, we're doing with our ecosystem partners. So between getting the chip back, publishing our real measured results when we have our silicon back, publishing the results of the MLPerf benchmarks, which we plan to do in the late third quarter, and then having real customer deployments. It's just a critical, huge year for VSORA in 2026.
Absolutely. I love it. All right. So before I let you go, Sandra, let's talk about your family llama farm. So, how did that come about? Talk to me about that.
So my husband is a big outdoorsman, and we actually, as a family, love to camp and hike. And when he was in the mountains of Colorado on his 2-week trip, a hunting trip with his friends, they realized that carrying up all of that weight, and certainly if they were successful in hunting, everything that they would need to carry down after a successful hunt, they actually wanted to have some help with that. And llamas are, as you know, pack animals that carry weight. So he started with the Fab Four, as we call them, the first four llamas. And as a family, we took the llamas with us. They carried all of our tents and camping gear, our food, our water. I mean, it was wonderful. We were hiking big, long, steep trails here in the wonderful Sierra Nevada mountains of California. And it was a beautiful thing. And our first four llamas, the kids helped name them. Dalai Lama, Lama Bean. We had Drama Llama and Michelle Llama. So that was super fun. But then my husband's hobby turned into an obsession. And today on our llama farm here in the East Bay of Silicon Valley, we have 32 llamas, all names, personalities. My husband knows them all. I can't confess to knowing all about them, but certainly he's the llama guy. And the neighbors love the llamas. They help feed the llamas. We take them to, the local little school on their garden day. I've taken the llamas to our company's family picnic. I mean, llamas are beautiful pack animals that are just wonderful to have and very easy to care for.
I love that so much. That is wonderful. Well, Sandra, it was a pleasure having you on. Thank you so much for joining me.
Thank you for having me, Amelia. It was really delightful to talk with you as well.
Well, folks, I must say that this interview is one of my favorite episodes of all time. Did you know that I have an Amelia's favorite episodes playlist on YouTube? This playlist includes my 500th episode with Mayman Aerospace CEO David Mayman. In this episode, David and I chat about his motivation to design jetpacks and air utility vehicles, and the evolution of Mayman Aerospace's Speeder VTOL air utility vehicle. Also included in this playlist is my discussion with Evan Coopersmith about the newest advancements in brain-computer interface technology. Evan and I also chat about the details of the Neural Latence Benchmark Challenge and how AI Studio is leveraging their expertise in machine learning to encourage innovation in BCI technology. And of course, my all-time favorite playlist would also include The Great Shark Cafe. In this episode, Rich Stump from Fathom and I chat about how Fathom is working with the Monterey Bay Aquarium Research Institute to create 3D printed video tracking devices for great white sharks in the California coastal region. And keeping with that theme, another absolute favorite episode of mine is about the Elephant Edge Challenge. Adam Benzion and I chat about this super cool challenge, what the Open Collar Initiative is all about, and how you can get involved to help save this vulnerable species from extinction. And amongst the rest of my favorite episodes is an oldie but a goodie called Vision Tech's Dirty Dealings in ICs. In this episode, I dig into the dirty dealings of component house Vision Tech. I investigate how one company from Clearwater, Florida, managed to dupe over 1,000 unsuspecting customers over $16 million, and how those counterfeit ICs have affected our industry. And there are even more amazing episodes for your listening pleasure in this playlist. And of course, I've included a link below the player on this week's fish frying page that will take you right there. And you can also find this playlist under the playlist heading on our EE Journal YouTube channel as well. And if you'd like more information about VSORA, I've also included a link below the player on this week's fish frying page on eejournal.com and in the description for this week's YouTube episode as well. Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EEJournal. If LinkedIn is more your thing, I dig it. You can follow me or us on LinkedIn, and we are also on Blue Sky Social and Mastodon too. And we have that YouTube channel I just mentioned, youtube.com/EEJournal. Folks, it is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series, hosted by me. And of course, you can subscribe to our EE Journal YouTube channel as well. Thank you everyone for tuning in. If you know of any cool new technology or heck you just want to chat, shoot me a line at Amelia, that's AMELIA, at eejournal.com, or post a comment on our forums on EE Journal. For the week of April 10th, 2026, I'm Amelia Dalton, and you've been fried.